the equation of hyperbola, we've got two different forms because we could have a vertically oriented hyperbola or a horizontally oriented hyperbola. So here are the formulas, and this can look very intimidating, but there's some key similarities between these two, some patterns to recognize. So first of all, notice that we've got our x minus h and our y minus k squared in both of these. Okay, and the x is over the a squared, and the y is over the b squared. And we're subtracting the two terms and getting 1. Okay? So the only difference between these two actually is the order between these two fractions. Okay, which one comes first? The one that comes first indicates the orientation of the hyperbola. So in this one, the x comes first. That is a horizontal hyperbola, meaning it will open horizontally like this. Vertical hyperbola, the y comes first. That means it looks like that. HK is the center, just as it is with the same form in ellipses and parabolas. And our vertices we get simply by adding or subtracting either A or B, depending on if it's vertical or horizontal, to either that x or y coordinate. Okay, so notice that for the horizontal, we change our x coordinate from our center. We add or subtract A. For a vertical, we go from our y coordinate k and plus or minus the b. And we have a nice property that our foci, the distance from the center to the foci, c, is given by this equation. C squared equals a squared plus b squared. Okay. And then finally, the asymptotes have slopes plus or minus b over a. Notice that's the number paired with the y over the number paired with the x. It's kind of easy to remember if you remember, well, rise over run, so y over x, those two constants with the y and the x. Of course, the asymptotes, they don't go through the origin, they go through the center. And so to get the equations of the asymptotes, you'd have to work with the center hk. You have a point and you have the slopes, so you can get the equations of the asymptotes.